So today we're going to talk about enzymes. The way you're going to recognize an enzyme is it's going to have an ASE at the end, which is the case for most proteins. So for example, you might see lipase or kinase, and that's going to tell you it's a protein or an enzyme. Now, the job of proteins is that they speed up chemical reactions in your body by acting as a catalyst. And this is super important for us because most of the chemical reactions in your body would go really slowly without these little guys to help, and you would be dead. So, way to go, enzymes. Now, the way enzymes work is they have this area on the molecule called an active site, which you can see here. With the arrow pointing to it. And this is the site where the reaction happens. So this thing called a substrate, or the reactants for your chemical reaction, will bind here, and the reaction will occur at this particular site. And when they're together, they form an enzyme substrate complex. Right, now, enzymes use something called an induced fit to make these reactions happen. And what induced fit means is that the reactants are not quite a perfect fit to the enzyme. It's more of it's kind of squishy. The enzyme will change shape to accommodate whatever reactant or reactants it's trying to combine or break apart. We used to think it was a lock and key model, so we used to think that the substrates or the reactants had to be an exact match for this active site, but now we know that's not the case. Right, now what happens is when the enzyme goes to speed up a reaction, the substrate or the reactant, whatever it's trying to put together or break apart, will bond to the active site. Right, the enzyme substrate complex will form, right, and then the reaction will occur. In this case, in the diagram you're seeing here, the sucrose is being split apart into glucose and fructose. And once that reaction happens, the products are released and the enzyme is free to do another reaction. And now this diagram can be a little bit confusing, so I've made it a little bit more concrete for you. So let's pretend that the enzyme is a toaster, right? And the substrate or the reactants that we're trying to change into something else would be a piece of bread. Alright, so the first step is that the substrate binds to an enzyme, forming this enzyme substrate complex. Alright, and we put the bread at a very specific spot on the in the toaster, and that spot would be the slots, and that would be your active site. Then the substrate is converted into the products by the enzyme. So that's like when you push the little button down on the toaster and it heats up and it turns your bread into toast. Right, and then next, the products are going to be released from the enzyme. So that's when the little lever pops up and your toast comes flying out of the machine, like this lovely toast that we're seeing in this picture. And then once you take the toast out of the toaster, it doesn't like blow up or anything. You could still use the toaster again, and that's the same with enzymes. So once it has done that reaction, it can do another one. The little toaster's like, yeah, I can make more toast. Awesome. Now there is a limit to how fast enzymes can work. The first limit is the number of enzymes. So let's say you wanted to make a whole bunch of toast. Or you can only make as much toast as the amount of toasters that you have. Right, and the same goes for the amount of substrate. You can only, do as many chemical reactions or as many toast-making processes as the amount of bread that you have. Okay, so how many toasters and pieces of bread or the amount of enzymes and substrate you have will determine how much of the end product you end up with. Alright, and also, number 3, if all of the enzymes have substrate attached or not. If you think about the toaster example, if all of the toasters currently have bread in them, you're going to have to wait until the reactions are finished to put more bread in them to make more toast. Right, so that's going to slow down the process a little bit as well. The last thing I wanted to talk about is something called denaturing of proteins. So if proteins, which is what enzymes are exposed to extreme pH or extreme temperatures, especially heat or strong forces, the proteins can unfold. So it alters their chemical structure. Okay, they come apart, and that unfolding process is called denaturing. Now, depending on how extreme that process was, the protein can recover. But if it was very extreme, then the protein will be denatured, completely. It won't be able to fold back together correctly, and it won't work anymore. And that's a problem, especially for your enzymes. They will not be able to speed up those chemical reactions anymore. And if you don't have those enzymes, it's going to cause problems in the body. It's going to start to shut things down. So for example, if you have a really, really high fever for an extended period of time, that can actually start to denature your proteins, and you'll start to see different areas of the body shutting down because it doesn't have those enzymes and proteins to function.